Thank you for reminding me. Okay, so now we're good. Okay, so Patrick put in some numbers that he output. I think those were the same as mine. They look very similar. But, so remember that the first thing that we're doing is we're taking the user input, which is going to be something like this, or we just go with 1, right? And then we're going to multiply that by 1 billion, etc., right? And that's going to give us the storage capacity of the drive, right? So that's the storage capacity. Now you have to go through and do each image type separately. Okay, so we have to take, and I'm just going to use the C here since you can't read the rest of it anyway. You take the storage capacity and you divide that by the resolution times whatever the number is, right? So we have different resolutions depending on, and by the way, you can do it separately, like I did it, like res, oops, undo, res equals 4,000 by 3,000. So if you do that as a separate line, then in your calculations, you just use res. And then you multiply that by the color depth, right? And I said for the color depth, you can do that calculation in your head and just use the number. And so you have C divided by res times the color depth for GIF. So this would be number of GIFs, right? And that's the color depth of 2. Is that right? Yeah.
Yeah, I'm following.
I'm trying to remember what the actual color depths are, since I don't have it in front of me. Where is it? Number, how many images? That's what I called it. There it is. I found it. The color depth of a GIF is, see, I thought I was wrong. The color depth of a GIF is 1. So we don't do a multiplication for GIFs. And remember I said if we use truncated, if we use truncated division here, that'll ditch the, thank you, Patrick. That'll ditch the remainder, right? So we won't get decimal or float results. And so we don't multiply the resolution for GIFs by anything, but we do divide by the compression ratio, right? So that would be like 5. And we do this first. So we have parentheses, and then you do the same thing, except for JPEGs, you would multiply it by 3 and then divide by, what is it? 5? Oh, 10. Right? Remember that we have to do this side before we do this. So this has to be figured out first over here on the right-hand side. And that would give you the number of JPEGs.
So,
right? And then you keep going.
So I did these like 4 separate calculations, well 5 including the capacity one, and maybe it's just something in my program that is not using
Are
the
you
right
making,
variable.
you're truncating here using the truncated division?
Yeah, I could share, but I don't want to take up too much more time. But yeah,
That's okay.
I have all of this exactly how you have it, and that's why I was
Okay.
so surprised I couldn't find my mistake. But maybe it's something wrong with like the variable I'm using isn't being used correctly in the program. So I might just have to go back and maybe
Yeah,
change
you
a
may
new
have to go back
variable.
and look at your actual variable names
Hmm.
and double check. We can look at it in lab.
Okay,
I can look at it in lab.
that sounds good. Thank you so much.
You're welcome. Because it's easier to see your mistake than it is for you to see your mistake. It's easier for me to see mistakes than it is for you guys. Okay, so, or issues. Any other questions? I'm happy to answer questions. I don't really have a whole lot to do today. I don't think. I think we're going to do iterations. Yeah, you can embed print statements, or you can comment out things and just do one calculation. So you can comment out lines. There's a couple of ways to do error checking. So anything else before I talk about what it is that I'm going to talk about? What is it that I'm going to talk about? I'm going to talk about, let's see, I'm on 3.4. What am I talking about? Okay, so we did the LF, right? That was, I think, the last thing that we talked about was the LF. So we're going to talk about while statements. So let me share my book, because what the hell? There we go. We talked about indentation. Oh, and by the way, I apologize for the video. One of the lecture video last time didn't process in YouTube, and I didn't notice that it didn't, because it takes hours and hours to process before it actually posts and goes live. And then for some reason there was an error processing it, and it didn't ever finish processing it. And yeah, so it never actually posted until yesterday. I noticed it and I fixed it. So I apologize for that. I'm sorry. But I want to talk about indentation again, because it's very important. If you don't have things indented correctly, things will not work the way they're supposed to when we're using if else, or if else if else. And by the way, it's elif, right? ELIF, but it stands for else if. And we use else ifs when we have multiple conditions that we need to check. So if you look at figure 3.15, and I can't highlight it because it's a PDF in this case, and it's in this box, so I don't know, it's some kind of weird format. But you can see that I'm checking for a condition. Grade is greater than or equal to 90. And I use the elif because I'm checking for a second condition. Right? Grade is greater than or equal to 80. So that's when we use the elif. Typically, we use one less else if than we have outputs. And I want to make this clear. So 1, 2, how many outputs do I have? Grade of A, grade of B, grade of C, grade of B, grade of E. 1, 2, 3, 4, 5 outputs. I have 1, 2, 3, 4 conditions that I'm checking for. And then I use an else. Because if all of these conditions evaluate as being false, then I just do this last bit, which is grade of F in this case. So here is another example, right, where I have a condition. Oh, I can highlight this one. That's nice. right? And if all four of these conditions are false, evaluate as being false, then I just do this last bit, the part that's after the else. So when you use an else, there's no condition attached to it. Okay. So let me scroll down. Iterative control statements. Basically, that lets us repeat a set of instructions. And there's, basically, it's what we call a loop. And here is the while statement. So basically, this will loop given a condition. So the loop will run while the condition is true. As soon as the condition is false, the loop will exit. So, what's important here is to understand that this is the whole loop right here, where it says while current, so that's the name of the memory spot that has a value in it, is less than or equal to n. And basically here we're just doing a addition, and then we increment current, and then what'll happen is it'll come back here and it'll check, because now if current was set at 1, so the first time it runs through this, let's say the user entered a value of 3, so n is 3. So the first time 1 is less than or equal to 3. So what will sum be? It'll be, sum is 0, right? So it's 0 plus 1 equals 1. So sum will be 1. Then I increment current by adding 1. So current is now 2. So is current less than or equal to 3? Yes. So basically I add current to sum. Sum is 1. So current is now 2. So 2 plus 1 is 3. I think I can do the math. And then I add 1 to current. So current would be 3. And then is 3 less than or equal to 3? Yes. So I do this. This happens one more time. So then my answer would be 6, right? 3 plus 3 is 6. And I increment it by 1. That brings the value in current to 4. 4 is no longer less than or equal to 3. So this part, which is indented by 1 indent after the while, stops running. And then it goes on to whatever else is at this level. Okay, so at this indentation level down below. And that's important to understand, that the loop, where's the loop here? Here is it starts on 11 here. And so this which will happen as long as this is which less than, not equal to F, and which is not equal to C. Now we use this for error checking a lot. So what we do is we check the input. And so here, the correct input, so this is a temperature conversion program, and the user is supposed to enter an F or a C. So what am I checking here? I'm saying, well, let's say the user entered a lowercase f. So that would mean that which is not capital F and not capital C. So what happens here is while which is not equal to capital F and which is not equal to capital C, it basically prints another line that says, hey, please enter F or C. into the input. And if they enter it incorrectly, the loop will check these two conditions and say, hey, it's still wrong, and it'll re-show this. And it'll try to do the input. And then let's say that they finally get it and they type in a capital C, say. Then it comes back here and it does match, right? This part of the condition, the AND part, which is not equal to C, evaluates as being false because it is C. So then it does not do this again, and it just moves down to the temperature equals, and it's the next input line. And then I say, if this is equal to F, we do this, else we do that. And then we output the Celsius. I actually have that program. I gotta put this in a corner here. There we go. So let me see, which one is this? This is the temperature conversion program. I have 3. Which one is it? You can see my code, right? Yes? Patrick says yes, so I'll believe him. I want to show you something. So watch my program. It says enter degrees Fahrenheit. Now this one is a little bit different, and I'll show you the other one in a second, but this one has something added to it that I want to show you. So let's say that I want to convert Fahrenheit into Celsius. That's all this one does. It doesn't go back and forth. So enter degrees Fahrenheit. I don't know, 100. And I press enter. And it says 100 degrees Fahrenheit equals 37.8 degrees Celsius. But look, the program didn't terminate. The program is now asking me a question. Would you like to enter another temperature? And so I can actually type in Y here, and it runs again. So I don't have to close this window, go back, hit run, right, to test multiple values. And this is something that I want you to implement from now on. I want you to do this so that you can run the program, whatever program it is, over and over again to test it multiple times, as long as it's functioning, right? Obviously, if you get an error, it's going to crash, but so that we don't have to jump through that extra step of closing the damn window, pressing run again, just to test it with multiple values. So now if I enter, let's say that what was yesterday? Yesterday was about 89. And so I can keep doing this until I decide I don't want to anymore. And then I press N, and it exits the program. So how do we implement that? Well, we implement that by using a while loop, or a while not. So they just use initialize. So here I'm initializing a variable. What does that mean? It means I'm assigning a value to a variable. We, as the programmer, are assigning the value. And we typically do that before we do the greeting. So we typically do that first. So I want to explain this. This is a variable called terminate. And I'm putting into the terminate variable false. Then I'm doing my program greeting. And here I'm going to have 2 loops. So here's the first loop. And by the way, all of my code is going to be in that first loop. So all of the code that actually does stuff. So here I'm saying while not terminate. Okay, I don't like that. So let me rephrase that. While, because they like to do negatives. Terminate is equal to false. And I'm not sure whether I have to put this in parentheses or not. So let me run it and check it. Yeah, no, I guess I don't. And
Equal,
what did I do
equal.
wrong?
Equal,
Thank
equal.
you. Thank you. See, I just asked you what it is that I did wrong. There we go. So let's run it, right? And I'll press no, and it exited. Oh, I should have pressed yes first, right? Because obviously I want to check yes. So let's run it. Press yes. It's working. Okay. Now, the reason I changed this is because it's a little bit, okay, so it says while not terminate. And basically that means while not terminate true. But we're still kind of beginning, except for Patrick. I'd rather we use a concrete value that we can understand. So here it says while terminate equals or is equal to false. So when terminate is equal to true, I want to exit the program. When terminate is equal to false, I don't want to exit the program. I just want to run the program again. Okay, so here is my code that calculates the inputs. Here I have the input for the Fahrenheit that the user typed in. Here I have where I do the calculation to figure out how much that is in Celsius. And here I output the degrees Celsius. And by the way, I formatted this to 1F because typically in Celsius you use 1 decimal point and you don't use more. And then I have this part. So I'll get to that part in a second. This would be the code that I have if I wasn't having that do you want to do it again bit. So this is just my regular code. So that goes in this loop. So this is all one loop. By the way, so is this. This is part of the loop. All of it. Why? Because of the indentation here. See, it's all indented one. So all of this code will only run if terminate is equal to false. If terminate is equal to true, none of this runs. So basically the program quits. So every time I run the program, I'm asking the user to please enter a yes or no. Would you like to enter another temp, right? Yes or no. So I have this bit. And I have a response. So the user is going to type in a yes or a no. So here I have input. Would you like to enter another temperature? Yes, no. So the Y or the N goes into, and I use lowercase, by the way, just because I find it easier to press one button than it is to press shift and another letter, right? So I used lowercase yes or no. And we'll talk about that too. Oh, I gotta get on it. So here I have another loop. while response is not equal to y and response is not equal to n. What does that mean? It means that the user didn't enter a y or a lowercase y or a lowercase n. So if they do that, I'm going to ask them to re-input their numbers. So let me show you that. Right, so let's say they entered G, which is not valid input, right? So what's going to happen? I'm trying to move stuff so that we can all see. What's going to happen is this is going to evaluate both sides of this, and actually both sides will of the and. Whoops. Response is not equal to n, and response is not equal to y. Those are true. One of those sides is true. Both sides are true. So if it's not y and it's not n, I'm going to ask them to do this again and try to do, and you can see that this is kind of the same thing, except I've rephrased my question. Oops, the green bit here, right? To please enter a y or an n. So let's see what happens. I entered a G, right? So now I press enter, and you can see it says, please enter a y or an n. And if I enter a capital Y, that's still not equal, so it asks me again. And this will go on until the user figures out whatever the hell it is that they, oh, I need to enter a Y or an N. So if they press Y, well, it wasn't supposed to do that. Yeah, uh-oh. Why is it doing that? It's not recognizing any of my input right now. So why is it not recognizing it?
Professor, you seem to spell response wrong in your coding.
Oh, that's what it is. I spelled it with an S. Okay,
you
so look.
You spelled it two different ways. That's what screwed you up.
Exactly. Yeah. So here, good call. Who said that?
It was me.
Amy? Oh, awesome,
Yeah.
Amy. Very good eyes. Excellent. Okay, so I spelled response with a C here and with a C here, but when I did the value assignment here, I spelled it with an S. So when I was typing in the yes or no, the Y or N here, it was putting it into a variable that was an S, that had an S in it. And then when I was doing this, when I was doing this condition check, response with a C still doesn't have a Y or an N in it. Right? Because when I did this one, I input the value into response with an S. So the fix here is to change that to match the rest. And with an S is the correct spelling, I think, yes. But then I have to fix more stuff, so I'm just going to leave it. If you spell something incorrectly, just make sure you consistently spell it incorrectly. How's that? So now I'm going to run the module again, and we're going to do that, and then I'm going to press G, right, and 7 and H, right? But as soon as I enter yes, a Y, hey, now it works. See, because now I put the Y in the correct variable. Right now, when I press N, this part, and this, by the way, is an if else, but there's no else because there's nothing else that I'm going to do. Okay, so when I press N here and input N, it exits the program. Now, why does it exit the program? So I'm saying here, if response is equal to the letter N, change the value in terminate to true. Now, the program jumps back up after line 33, actually, because I have an extra line here. Another reason why to turn on your lines, because see, I had an extra line. It comes back up here, and now this loop is no longer correct, right? Terminate does not equal false, so this condition evaluates as being false. So none of this runs anymore because all of it is part of the loop. And by the way, this is a loop, and as long as the user doesn't type in Y or N, Y or N, this is going to happen over and over. Is that better, Sevilla? Yeah, okay. I maximized it. So this is a loop. Just this part, not the if, because the if is on the same level as this loop. Okay, so does that make sense? Sort of? Does it? Do you understand? Yes, no, maybe? Yes, please, yes. Okay, so we tend to use loops, and we're going to use loops a lot for error checking. So we check the user input to make sure that it's the correct kind of user input. And I like being able to use the program multiple times without having the program exit and having me restart it. So we're going to use this kind of terminate loop a lot. So this bit. We're probably going to do this with all of our programs from now on, starting with today's. Okay, so let me close this. Did I make a change? What the hell? I'll press yes. So the book has this whole section on input error checking. Most of the time, we have a limited number of inputs that are valid inputs. And so we tend to use the is not equal to instead of is equal to. Because right here I have two valid inputs, a capital F and a capital C. So there are only two inputs that are valid. How many invalid inputs are there? Well, I guess there's an infinite amount of invalid inputs, right? So I don't want to check for the invalid one. So the way I check to see whether it's invalid is I say, hey, if it's not an F, right? If it's not a capital F, then it's all of the other input that it could possibly be. But there is one other input that's valid here, and that's a capital C. So I check to see whether it's a capital C. And if it's not either one of those two things, I ask the user to please input an F or a C, right? Because they haven't. So we tend to use the not equal to. If it's not equal to this and it's not equal to this, then ask the user to input the correct thing. And we do a loop because they could still enter the wrong thing, right? They could enter the, I did it a bunch of times. I entered the wrong thing a bunch of times, right? So I want the loop to keep running. And by the way, this is what we call a It's not an infinite loop. It's an indefinite loop. This is basically, oh, look, they even use it down here as an example of an indefinite loop. And basically what an indefinite loop means, it's defined as being a loop that we as the programmer don't know how many times it's going to run, if at all. So this loop right here, well, will run as how many times? Well, it may run 0 times, right? The user may type in the correct input right away. So it may not run at all. Or it might run once or twice or however many times the user enters incorrect input, right? Until both of these conditions pass, are evaluated as being true, this loop will run. So we don't know beforehand how many times that's going to happen. The end user determines, right? The person using the program determines if the loop runs and how many times the loop runs. A definite loop, on the other hand, is one where we can figure out how many times the loop is going to run beforehand. So, for instance, if I have a program that adds numbers, I think I have a loop example here. Let me see what I got. Oh yeah, this is a loop example. So can you see my code window? I think I'm sharing the screen, so I think anything that's here. So here, this is like the example in the book, where I'm just going to keep adding 1 to current and then add current to the sum. And here I'm actually printing the sum. So I'm actually showing the output. How many times is this loop going to run? It's going to run n times, right? Where does n come from? It comes from user input. So the user is going to type in a 5. If they type in a 5, this loop is going to run 5 times. Because it's going to run as long as current is less than or equal to n. I think it's going to run 5 times. Let's run it, see what happens. So if I do 5, right? Did it run 5 times? Watch what I'm going to do. So watch carefully. Pay attention, everybody. Is everybody paying attention? Okay. I'm going to make a change here. Okay, so let me run this one more time. Okay, so I typed in 5. And look at my output. My output is just 15, right? So it's one number that's being output. What did I just do? I know that I tabbed print over, right? But what did that do? He asked, where's my chat room? Eduardo, be a little bit clearer. Yes, Summer, very good. And I think, yes, it put the print inside the loop, right? So just by doing that one tab, I'm going to get as many outputs. This is going to run every time, and then it's going to go back to here and run again, and this is going to run. So it changes drastically. That one little tab changes drastically how my program works. So if I put 5 here now, look, I have 5 outputs, I think. 1, 2, 3, 4, 5. And I wanted to show you how many times the loop was running, right? And so by doing this, I'm able to see, hey, the loop is actually running 5 times to get to 15. So it's actually displaying the sum every time. So the first time it's 1, the second time it's 2, the sum is 3, and then it adds, it goes to 6, and then it adds 4, and then it adds 5. The next time it would add 6, the next time it would add 7, 8, 9, 10, however many times this loop goes. Actually, it would add more than that. So let's run it again, and I'll put in a bigger number. Let's just do 55 times. And it's showing me each one of my outputs, right? So this is, and by the way, if I do that again, and I run this, and I type in 55, it's only going to show me one output, the final one, right? This is the last number. 1540 is the last number. Because this loop runs and it keeps adding to the sum over and over again. And then when it quits, right, this keeps going over and over and over again, 55 times, if you enter 55, right? And then it does this once. If I do that, it does this print line 55 times. Oops. Undo, by the way, works. Control Z. So undo is my friend. Okay, so that's my loop example. It's not a bad example. I do want to, what time is it? Oh, crap. I do want to talk about this a little bit. And how do I want to talk about this? I want to talk about this by doing this. Okay, so whenever I need to add to, this is called a running total. Okay, so if I have, and I'm just going to use x equals x plus something. I'll just say 2. So, and let's say that x is equal to 0. Okay, and let's pretend that this is in a loop, or that this is a running total of some sort, and I'm going to keep adding to it. Well, this is a running total. This is how you do a running total. So remember that we start reading stuff over here on the right-hand side and then go like this. So, and that the code will execute like this. So the first time that this runs, this would be a 0. And we know that 0 plus 2 is 2. So what happens is, once this is done, this addition, the 0 is overwritten with a 2. So we're, right, I said x is equal to 0, so that's the memory spot. The variable has a value of 0 in it. So the first time through, it's 0 plus 2. But then because of this equal sign here, I have overwritten the previous value with the new value. So if this was to run again, without having this, right? So just this line. Now x plus 2 is no longer 2, it's 4, right? Because this is 2. So it does the addition on the right-hand side, comes up with the answer, and then it overwrites the value that's being held in my variable And so that changes to a 4. And this will go on, and this is how we do running totals. And so, right, the next time through, instead of this being a 2, it's a 4. And 4 plus 2 is 6. So we would overwrite, or it will overwrite, what's being held in the x variable to a 6, etc. So whenever we need to do running totals, the way it works is whatever the name of the variable is equals itself plus whatever it is that we're going to add to it. However simple or complicated this is, whatever it is that I'm doing here, right? So it's whatever the name of the variable is equals itself. So basically you have the same, like here it says sum, right? So it's doing sum equals sum. And if it was a different variable, say it was input equals input. No, it wouldn't be input. That's bad. If I named my variable Bob, it would be Bob equals Bob, and then plus whatever it is that I need to add to it every time. Because it's overwriting the previous value. So remember that what happens to the right of the equal sign happens first. Okay, that's another thing that's important to remember and to understand. So is that kind of clear to everybody? Yes, maybe? Yes? Okay, good. Because it's one of those kind of simple things that can screw people up. So I want to make sure that everybody is good on that.